Okay, this is going to be really important for those of you going on to AQR and on to pre-calc. And then also for those of you going on to statistics, you're going to need this. So the first thing to fill in here is that a rational expression is a ratio of two polynomial expressions. Okay? Now what you're going to want to do is you need to all we're doing is simplifying fractions here, but in simplifying fractions, remember we have to cross out chunks that match. So for example, in number 1, y plus 7 matches the chunk y plus 7, so that can be crossed out. So then we're left with 3y over y squared minus 9. Now here's the deal. You cannot let the denominator become 0, because remember we can't divide by a 0. So we have to go back and we have to decide what can y not equal. So we're going to take our denominators and we're going to say y plus 7 cannot equal 0 and y squared minus 9 cannot equal 0. So we're kind of doing the zero product property. We are doing the zero product property to find what y cannot equal. So in the first case here, y cannot equal -7, because if I put -7 into the original expression, it would be -7 plus 7, which is 0, and 0 times anything is 0, making the denominator 0, which is not okay. So then the other thing that we have to eliminate here is that y squared equals +9. So we're going to square root both sides. But remember, in square rooting both sides, that creates two solutions, a plus minus 3 here. So y can't be plus minus 3 either. Okay? So there's that step that you have to watch. Now in problem 2, you can't cancel out until you have chunks multiplied by chunks. And here we just have a bunch of p's with plus or minus separating them. So we have to factor this into chunks. Now I'm not going to sit here and spend all the time factoring. If you don't know how to factor, you need to go figure it out. So I'm going to give you this. This is going to be p, and this is going to be +3, and this is going to be -1. Okay, so I factored that, and that's what I got on the top. So that's what that equals. I'm going to cross that out. On the bottom, it's going to be p minus 5, p plus 3. Okay, so that's crossed out. Now what can cancel? What chunks can cancel with what chunks? We can cancel p plus 3 and p plus 3 because they're both chunks. And that's going to leave us p minus 1 over p minus 5. Now, we're going to be tempted to cancel out those p's and make it -1 over -5. But that's not, because of it's not multiplication, you can't just cancel. You have a subtraction problem over a subtraction problem. So you can't take pieces of subtraction and addition problems, okay? Now again, we have to decide what p can equal. So in the bottom, p minus 5 cannot equal 0, and p plus 3 cannot equal 0. So p cannot equal 5, and p cannot equal -3. If we let p become one of these, then we end up with 0 in the denominator from our original, and that's not okay. Now in this one, it looks like it says you can factor out a minus 1. We're going to be using this. We're going to factor out a -1. I need to make my pen a little bit less thick. Okay. So the first thing is to factor, because we have plus and minuses here. We can't just start factoring. We can't just start crossing out things. We have to have chunks. So in the top, we can factor out an a to the 4th. That'll leave us with b minus 2 in the numerator. Okay, so I factored out an a minus 4. The GCF in the denominator is going to be a to the 3rd. That's going to be 2 minus b. Now it looks like we might be able to cross it out, except the chunks don't match exactly. b minus 2 is not exactly the same as 2 minus b, and that's because the b in the bottom is negative, the b in the top is positive. So that's where this little hint comes in here. In the bottom, I'm going to factor out, I'm going to keep my a to the 3rd, but I'm going to factor out a -1. What that does is I'm dividing each thing by -1 here. So that gives me a -2 and a positive b here. On top, I didn't do anything. Now you don't have to switch the order, but maybe you're not seeing that those chunks match yet. So let's switch the order so they both look the same. And that would be b minus 2. Now what can we factor out? Well, our chunks here match now, so they go away. Now we have a to the fourth over negative a to the third. Well, how many of the a's can cancel out? 3 of the a's will cancel out, leaving 1 in the numerator, which means I have a over negative 1. That can simplify down to negative a. Okay? And then we're going to come back to our denominator and say a to the third cannot equal 0. So if I take the cube root of both sides, a cannot equal 0. The other thing, 2 minus b, cannot equal 0. So I subtract 2 from both sides. Negative b equals can't be negative 2, so b also cannot be 2. Okay? So again, these are going to be part of the solution. You need to tell what the variable cannot equal. Okay? Okay. To multiply two rational expressions, you multiply the numerator times numerator and denominator times denominator. It's just, how do I multiply fractions? Top times top, bottom times bottom. Okay? And then, and I hate to say this, but I will, we are going to divide two rational expressions. We multiply by the reciprocal. And back in elementary school, they gave you a little trick where they said copy dot flip. Now, some of you have no idea what that means. Don't worry about it. I'm going to show you. That's just a device, which it's not my favorite, but it's been used a lot, so we use it. So in this case, I can start looking at this, and I can start simplifying numerator and denominators. I'm going to show you two different ways to do this. So the first thing I'm going to say, well, I have an 8 up here, and that can cancel with a 16 down here. 8 over 16 is 2. That works. I can cross a 7 out here and a 21 down here, and that gives me 3, because 7 into 21 is 3. Now let's look at our x's. Well, I have one x on the top, and I have an x to the third on the bottom. So what's going to happen? One of the x's is going to cancel out on top and bottom, leaving me with an x squared on the bottom. Now, we also have y's in top and bottom. Now, you can only cancel top to bottom. And in this case, we have 2 y's in the numerator and 3 y's in the denominator. So we're going to cancel out the 2 here and cancel out 2 here. We're left with a y. So really, we're not left with a 0 in the top. We're left with a 1. These are all 1's here. Okay, so 1 over 2 times 3 is 6, x squared y. Now I want to show you that in a different way. Some of you are perfectly fine just canceling out from the original problem. So make sure you copy that down or pause it, because I'm going to erase it, and I'm going to do it a little bit different for those who might need to see it a little more organized. Okay, so here's a little bit more organized. And most of you probably won't have to continue doing this, but just to give you kind of a hint to how to make this a little more organized. I'm going to do 8 times 7 over 21 times 16. I'm gathering all my numbers together. Then I'm going to gather my x's together, and I'm going to gather my y's. And now I'm going to do simplifying in each piece. Okay, this still means the same thing. I'm just doing it in each piece. So 8 goes into 16 twice. 7 goes into 21 3 times. That leaves 1 over 6. This one can cancel with this, leaving x squared. And this can cancel 2 of those, leaving y. Again, that's going to give you the same answer of 1 over 6 x squared y, but it's just a little bit more organized if you want to rewrite it. Okay? Let's look at b. Now b, before you start canceling, we have this out here. So we have to take care of that first. So really what we have is, whoa, that's not going to work. We really have 5a to the fourth c times 3 to the third, that's 27, b to the third, and power to a power we multiply. Then we have 12b on the bottom, 15a to the third b squared. And again, you can reorganize them and rewrite them, or you can just cancel from here. So let's watch what happens. 5 cancels with 15 and makes a 3. 12 and 27, well, let's do this. 3 goes into 27 9 times. Now 12 and 9 actually have a common multiple, and that's, or factor, that's 3. Woof. So we can divide the top and bottom by 3. Well, if I divide 9 by 3, I get 3. If I divide 12 by 3, I get 4. Okay? Now I'm done with my numbers. So maybe you want to write out your numbers. I have a 3 in the top and a 4 on the bottom. You can wait to the end to do that or do that now. Now I'm going to check out my a's. I have an a to the 4th in the numerator and a to the 3rd in the denominator. So 3 of the a's are going to cancel out, and that's going to leave me with 1a in the numerator. A's are taken care of. Now b's are a little different here. Now some of you probably see this right away. We have three b's in the denominator because we have a b to the 1st, a b to the 2nd in the denominator. So that's actually b to the 3rd. So that can cross out the b to the 3rd. The b's actually go away. Okay? Now we don't have any c's in the denominator. We only have c's in the numerator. How many do we have? Well, we have 1 here, and we have 6 here. So total multiplied, we have c to the 7th. And this is our final answer. Okay? It does take some practice, so you might want to go watch it again. Now here's where we have to simplify division. Division means the same as multiplying by the reciprocal. So that means we leave our first fraction alone. We change our division to multiplication, and we flip over the next fraction. That's where the teachers got copy dot flip. Okay? But we're actually multiplying by the reciprocal. Once we're multiplying by the reciprocal, we're back to doing what we just did. Okay? There's no perfect place to start, but I see 3 can go into 6 2 times. I can see 5 can go into 10 2 times. The p's cancel out. The c squares cancel out. Now I have 1 s in the denominator and 2 s's in the numerator. That means I can cancel out one of the s's in the numerator. I have 2 d's in the numerator and 1 d in the denominator, so that leaves me with 1 d in the numerator. And then I just see what I have left. I have a 2 sd. And I can put the 1 under here if I want to, but I don't have to. And that would be your final answer. Okay, let's look at this one. Again, before we do anything, I'm going to change this to multiplication. So I'm going to leave the first fraction alone. Now see these as chunks. These have to travel as chunks. Times the reciprocal of k squared minus 1, k squared minus 4k plus 3. Well, all the chunks we have right now are not going to work. So there must be some factoring that I can do. And there is. So in the bottom here, I can factor this into k minus 3, k minus 1. So I'm going to cross this out because I factored it. And then the one on the top is the difference of 2 squares. And again, you might have to do the work for this. I happen to know the pattern of the difference of 2 squares. So this is k minus 1, k plus 1. Now I have some chunks that can cross out. In the numerator, I have a chunk of k minus 1. And in the denominator, I have a chunk of k minus 1. So I'm going to cross them out. This is coming out different than I did before. What did I do wrong? Nothing. All right, and then I have a k minus 3 and a k minus 3. They go away. Just making sure I didn't do anything wrong. And then I have a k plus 1 and a k plus 1. Okay, the answer here is not 0. The answer here is 1 over 1. All we're left with is 1 over 1. So our final answer is 1. That's a dumb looking 1, but that's my 1. Okay? All right, let's go to this one. Now it can get a little more complicated. Great. So again, I have division. So before I do anything, I need to change it to multiplication. I need a little more space there, so let me fix that. So 2d plus 6. We leave the first fraction alone. And then we multiply by the reciprocal of the second fraction. Now our hope is that there's chunks that match, but in this case, none of these chunks match. This one can't be factored, so I'm just going to put parentheses around it because it's already done. The top one can be factored into d plus 2, d plus 1. Okay, so I'm going to cross that out because now I factored it into chunks. This one here, the top of the first fraction, you can factor to GCF of 2, leaving you with 2 as my one chunk and d plus 3 as my other chunk. I undistribute it there. And then in the bottom here, we make them so they work. D plus 2 and d minus 1. If you don't know how to factor, you need to go watch the videos. Now we just cross out our chunks. All right, let's see what chunks I have. D plus 3, go away. D plus 2, go away. Now here you're going to be tempted to cross out the d plus 1 and the d minus 1 or take out a negative. That's not going to fix anything. So my final answer here is 2 times the quantity d plus 1 all over d minus 1. There's nothing else that you can do here. D plus 1 and d minus 1 cannot be created to be the same chunks. Okay? Okay. A complex fraction looks a lot more complicated than it is a rational expression whose numerator and denominator contain a rational expression. Now that sounds confusing, but what this means is we have a fraction in a fraction. Sometimes we have two fractions in one fraction, sometimes we have one fraction, but it looks gross. Don't panic, it's not much different. To solve a complex fraction, rewrite it as a division expression. So for example, here's our complex rational expression. I'm going to do this. So this is a fraction, and we're going to say divided by another fraction. So let's rewrite it in that way. So we really have x squared over 9x squared minus 4 divided by x to the third over 3x minus 2. Now we just have what we were doing above. We're going to rewrite the first one, and I need some room here, so I'm going to shrink this down. I'm going to rewrite the first one. I'm coming down here. X squared for 9x squared minus 4. Change division to multiplication and multiply by that reciprocal, so I'm flipping this one over. Okay? Now I'm going to see if there's any chunks that match. There's a chunk. This is a chunk of its own. This is a chunk of its own. Something must be able to factor in the bottom there. And it is. That's a perfect square minus a perfect square. This is the difference of two squares. So this can factor into 3x minus 2 and 3x plus 2. And again, this is all about factoring, so you might need to go practice that. Ow! Sorry, my cat just grabbed me. So we're going to cross out our chunks. 3x minus 2 matches 3x minus 2. Now we have x squared on the top, and that can cancel 2 of the x's on the bottom, leaving me with an x. Our numerator then is 1, because everything in the numerator crossed out. Our denominator is x times the quantity 3x plus 2. Okay? And that's my final answer right there. And that's how you multiply or divide rational expressions.